Okay, thinking back to before Christmas. X squared plus 21 equals 70. If we're going to solve that, you got to start by moving that 21 over and subtracting it. So x squared is equal to 49. To unsquare it, you're going to square root both sides. So x is equal to, you got to have two answers, so you make it plus or minus. The square root of 49 is 7. So that's your answer. Same thing here, we're trying to solve for x. We start by moving the 12 by adding it. So 4x squared is equal to 25. You've got to move your 4 by dividing. So x squared is equal to 25 over 4. So we're going to square root both sides, and you get x is equal to plus or minus. Square root of 25 is 5. Over the square root of 4 is 2. That's your answer. Move your 4 by subtracting. So x minus 3 quantity squared is equal to 36. You're going to go ahead and square root to get rid of that x squared. When you square root on the left, it becomes simply x minus 3 equals plus or minus 6. You've got to move that 3, so you get two answers this way. X is equal to 6 plus 3 is 9, and x is equal to negative 6 plus 3 is negative 3. So you have two answers this time. Okay, that's just a review. That's things we've worked with in the past that you already know about square roots. So, another review of quadratic functions. If they give you the equation y equal x squared, you would put that in your calculator at y equal, and you would look at your table. Then you could fill in the table they gave you. When x is negative 3, y is 9. For negative 2, you get 4. For negative 1, you get 1. 0 is 0. 1 is 1. 2 is 4. And 3 is 9. Then you plot these points. You would go left 3 up 9, left 2 up 4, left 1 up 1, 0, 0, right 1 up 1, right 2 up 4, and right 3 up 9. So this is what your table looks like. This is what your graph should look like. It's okay if you just have the dots and you did not connect them and make the line on your graph. So if the domain is negative 3, negative 2, negative 1, 0, 1, 2, 3, what would the range be? Domain, remember, was the x values, and so your range is going to be your y values. You do not list each one twice. It's okay if you did it from smallest to biggest. Is this equation a function? Yes, it is. You would actually, instead of their answer, which I don't really like, say x does not repeat, or it passes the vertical line test. Okay? You've seen this before, you've done this before. Another thing that you've seen before, but it's been a while, is inverse with coordinates. Remember that to get the inverse when you have points is you just switch the x and y. So you're going to take the y values that you wrote in number 1's table and move them to this new table, except they'll be your x values. Then you plot those points and you will have the graph of the inverse. Once again, you don't have to have a line, you can just have the dots. So, was this new inverse a function? The answer is no, because it fails the vertical line test, or x repeats. We also learned how to find the inverse using algebra. You take the equation and you switch the x and y, and then you solve. So y equal x squared becomes x equals y squared. And then we've got to get y by itself, so we're going to square root both sides. So the square root of x is equal to y. So when you put that in function notation, f negative 1 of x is equal to the square root of x. If you were to put that in your calculator at y equal, you would get a graph that looks something like this. This graph does not match the graph we got in number 2 because it doesn't have the bottom half. Next page. These two relations they've given you are inverses. Okay, the graph on the left you already have. The equation that was graphed there is y equal x squared, and this is a vertical or upright parabola. We're going to draw the graph on the right. It's the second graph that we found. It was for x equal y squared, or y is equal to the square root of x. And it is a horizontal or sideways parabola. Okay, so some of the properties of inverse, the graphs are reflected over the line y equal x, and their equations have the x's and the y's switched. The problem with the new graph is that it is not a function. It fails the vertical line test. So normally we just graph the top half and we call it the square root function. So here is the parent of the square root function, y equal, or f of x equals square root of x. They made a table, they plotted points. The domain for this is x is greater than or equal to 0. Remember, x is going left to right on your graph. It would only be all real numbers if it went forever left and forever right. It starts at 0. You might have written this 0 as less than or equal to x, because you can only use positive values for x. You can only find the square root of a positive number. The range, remember, is y, so it is going from the bottom to the top. And so either 0 is less than or equal to y, or y is greater than or equal to 0, because you will only get positive answers for y. Okay, that was squaring and rooting. You have a worksheet that goes a lot like the front of the notes. If you have questions, come see me during speed.
Where's the school at?
I don't know. I like the question.